generating long-reaching lahars which could become several hundred feet high. In fact, looking at Mount Baker's hazard map, nearly 87,000 people live in a lahar risk zone, a figure only second within Washington state to Mount Rainier. 4 such large lahars were generated in the last 10,000 years, some possibly due to eruptions, others by non-eruptive processes. Taking this into account alongside Mount Baker's recent high eruptive rate is why this volcano is classified as a very high-threat volcano. In fact, an intrusion of magma recently occurred underneath 1975 magma intrusion Mount Baker's edifice in 1975, but remained fairly deep and did not result in an eruption. However, while declining year over year, Baker has been degassing at an elevated level ever since via its fumaroles, so if you ever see a gas plume rising from this volcano, that will likely be why. Baker Volcanic Field Mount Baker and its surrounding region that include the Kulshan and Hannigan caldera mark what are known as the Baker Volcanic Field. Volcanic activity in the last several million years has seemingly shifted southwestward over time, with Mount Baker only truly beginning to form 495,000 years ago. Like all other Cascade Range volcanoes, Mount Baker began erupting due to the subduction of the Juan de Fuca Plate underneath the North American Plate. The initial geologic history phase of activity at Mount Baker was marked by a combination of explosive volcanic eruptions which ejected ash alongside the emplacement of andesite lava flows. This initial eruptive center built a central cone that likely towered at least 1,000 feet higher than the modern Mount Baker, resulting in glaciers forming on its edifice. These same glaciers later almost completely eroded away this originally taller satellite cone which is today referred to as lava divide. At the latter stages of lava divide's eruptions, andesite lava erupted at what would become the tallest peak of Mount Baker, with additional lava flows erupting all the way up to 366,000 years ago. The Black Butte satellite cone then became the dominant vent for a time, growing between 350,000 and 288,000 years ago. Around 140,000 years ago, with a tall cone to the northeast and another one to the southwest, that Mount Baker's main cone became the dominant vent. However, its eruptions for the next 100,000 years were highly explosive, producing minimal lava and large amounts of ash in explosive eruptions, with this fact largely preventing the edifice from quickly growing. It wasn't until 40,000 years ago when its eruptions suddenly became less explosive that a major period of cone growth began. That means that yes, almost all of the summit area was created since then via more than 100 distinct explosive and effusive eruption in that timespan from the now buried Carmelo crater. Interestingly, a flank cinder cone known as the flank cinder cone Schreiber's Meadow Cone formed approximately 10,000 years ago to the south of Baker's summit, generating a 12-kilometer or 7.5-mile-long basaltic lava flow. However, all eruptions since 7,500 years ago have originated from a separate vent half a mile south of its summit at Sherman Crater. Several large lahars also occurred during this timespan between 4700 BCE and 3800 BCE. Then, 1800s eruptions. No additional volcanic activity was recorded at Mount Baker until 1820, when a phreatic eruption occurred on the summit. An eruption an order of magnitude larger occurred several decades later in 1843, which also generated a lahar. From 1846 until 1880, as many as a dozen additional small phreatic eruptions occurred from Sherman Crater. If Mount Baker was to erupt again, its most likely source would be from Sherman Crater. As a final note, I would like to thank this channel's patrons on Patreon and